here's my shape. And we're just going to go through the same process we went here. There's one slightly tricky thing in one of the calculations. Oh, did y'all notice we are being recorded again? We have a much better system. So there's some technical details about trying to get it up on YouTube. It should be up shortly. Do that as soon as I can. Technically, it's up. So everybody's good with all the lectures being recorded, and you're not going to quit coming to class? I just actually saw a study this morning. They came up with a meta study of all the different studies of what predicts student success. And you know what the number one predictor is? Attendance, absolutely right. So more than anything else, it's attendance is the best predictor of how well you're going to do in school. Let me pause. So let's do x bar first. And x bar is a fraction. Get this pen to last as long as I can. What is the numerator of this fraction? It's the sum of something. It's terrible. Sum of what? Sum of the moments about 0. And what's the denominator here? Again, technically it's the total weight, but we adjusted the density to 1. So the weight is equal to the area. And areas of shapes like this are exactly what integrals were invented to do, or at least the first thing. This is how we introduced integrals in Calc 1, is how you find the area of the shape like this. And that's just the integral of the function from 0 to 2. And I'm thinking about the top now. So I want to do the moment about x equals 0. Is x equals 0 a horizontal or vertical line? Agreed? And how do I calculate a moment? It's the distance. And technically it's a distance times a mass. Instead of mass, what am I going to write here? Area. So once again, we adjusted the density to 1, so the area is the weight. So I'm trying to make a slice out of the original region so that all the points in that slice have the same distance from x equals 0. Would I use a horizontal or a vertical slice? I want all the points to have the same distance from x equals 0. So they have to look like this. So for that first calculation, the distance from x equals 0 is that horizontal distance. What letter measures horizontal distances? X. And specifically, x is the distance, the horizontal distance from the y-axis. So this is exactly x. And then for the area, is I need to do base times the height. Is this base a dx or a dy? It's a dx. So it's a blue slice of the x-axis. And for this vertical distance, for the height as a vertical, the top is given by y equals x squared. And the bottom, we don't need it for this one, because we have it to get into, is given by y equals 0. So what's the height of this rectangle? X squared. So for the area calculation, it's going to be x squared times dx. So this is the moment for one slice. And then for x bar, we need the sum of all these moments. add these up from 0 to 2, x times x squared dx. Y bar next. One thing you want to be careful of, x equals 0, algebra students refer to that as the y-axis.